So today we'll be talking about the module 7, which is descriptive statistics. So we have covered the data visualization modules such as Matplotlib and Seaborn in our previous sessions. Now it's time to move up the ladder and move towards the descriptive statistics. So let us try to understand the next phase of the data science journey, which is descriptive analysis or descriptive statistics as we may call it. Yes, okay, great. So what is descriptive statistics? So as the name suggests, from the name itself, we get a hint that it is something that describes our data. In other words, it is a technique where we try to explore our data to understand the relationships between our data and try to get some insights. How my data looks, what are some nitty-gritties of the data, and onwards. So descriptive statistics are used to explore and describe the data. So whatever values are there in the data, how can I describe it? Measures of central tendency, which basically includes the three major statistics, as we call it: mean, median, and mode. Then we'll also look at the measures of dispersion, how my data is spread across the mean, how it is distributed, where we'll be covering the range, variance, standard deviation, and IQR. Then we'll be covering the confidence interval of a measure, where we'll be talking about what is a population, what is a sample. Next, we'll be talking about skewness and kurtosis, which basically helps us to describe our data further. What does a data with high skewness means? Similarly, what does a low skewness means? And similarly for kurtosis. Two different measures. Then we'll also look at the bivariate measures of analysis such as covariance and correlation. All right, so we'll be covering that in the descriptive analysis part. Before moving on to the specific descriptive analysis, let us talk about statistics as a whole. So there is a very famous quote in statistics. There are two kinds of statistics: the kind you look up and the kind you make up. So we'll be in this particular session or in this particular lesson, we'll be talking about the first one, which is the kind you look up, which basically means the data is there, you just need to understand it, right? All right, so let us first understand and bring everyone of us on a similar understanding of statistics. What is statistics? A statistic is a branch of mathematics that deals with collecting, organizing, analyzing, and interpreting data. So it starts with collecting the data, right? It can be a survey, it can be a web form, or it can be just getting any dummy values or simulations. Organizing, which basically means converting it into a required format, in the format which is suitable for analysis. Once the data is suitable for analysis, which means it is organized, we move on to the next step, which is analyzing it. And then based on the results of the analyze, we can interpret our data. For example, 50% of the people in this class are between the age of 25 to 30 and so on. So these are all interpretations. Once we have the data, we organize it, we analyze it, and whatever conclusions we derive from it, we interpret it. That is all statistics is all about. Okay, so let me give you a background about why statistics is important while doing data science. So data science is a very newly coined term, but statistics has been in the system, has been in the world since decades. It has been in the systems when there was a language. Whenever there was a language, it is there from there. Data science is a very newly coined term. It was not existing 10 years back. Nobody used to coin this term data science. It was statistics. So it was the statistics that was computed on very small sample sizes of data. right? Data science also involves the same steps: collecting, organizing, analyzing, and interpreting it, right? It involves the same steps, or I would say similar steps, but what changed? It is the volume of data, it is the type of data, it is the veracity of data that changed. That is what that is what led to the evolution from statistics to machine learning algorithms to deep learning algorithms to data science, right? It is that volume of data, it is that different types of data. Statistics we used to perform only on tabular data: average height, average population of average population of countries, the GDP of different. Give me 1 minute, guys. Sorry. Yeah. So what was statistics? It was basically deriving some information, right, from the collected information. But in the times of statistics, it was very small samples of data. Whereas today we are talking about GBs, TBs, and also petabytes of data. So that is what led to the evolution from statistics to machine learning. But if you observe carefully, the working of these algorithms, the backend, if you look at the maths behind this algorithm, for example, linear regression, logistic regression, decision trees, it still is backed by statistics and maths, right? It is still based on probabilities, it is still based on different situations, scenario analysis, simulations. What are this? These are nothing but a part or a branch of statistics only, right? So that is why although statistics is a subject which is a few decades old, but still it is relevant. The only fact that has changed is you don't have to do each and everything manually now. There are algorithms, there are ready-made algorithms that handle the maths part of it. What we as a data science, most of our data science, what we have to do is derive what are the applications of these algorithms, or in other words, when to use these algorithms. That is the only task we have, right? Somebody already smarter than us has coded all this maths, has coded all the statistics, and created it in a function, a user defined function, which has now been available to us in a form of a module or a library or a package. We just have to use it, apply it, and get the job done. All right. So this is why statistics is very important part of machine learning, because if you want to understand the maths, you always have to understand the statistics.